All right, example 2. For the quadratic function y equals 1/4 times x minus 3 squared plus 1, identify I, direction of opening, I, vertex, I, equation of axis of symmetry. I know that it's actually 1, 2, and 3. I'm just trying to be funny. 4 intercepts, so x and y, and 5 domain and range. The B part of it is going to be sketch of that graph. All right, so some of these questions are going to be easier to answer than others, faster to answer than others, so I might have to erase this. So copy it down, take some time. I'm just going to section it off so I don't get super messy with my explanations. So, A1, identify the direction of the opening. Well, my A is positive, so it's going to be opening up. Done. I? Just joking, that's going to get really annoying. 2, the vertex. Well, I know that this is my x coordinate. So positive 3, guys, not negative 3. Because remember, it's moving to the right 3. So 3 and 1. So it's opening up, and the vertex is at 3, 1. 3, the equation of the axis of symmetry. Well, we know where we get this from, folks. We just get it from the x-coordinate of the vertex. X equals 3. Remember that equation of, the axis of symmetry is where the parabola is the exact same on one side and on the other. Intercepts. Now here's where it gets a little bit interesting. In standard form, finding the intercepts, especially for, which ones? Your y-intercept, it's pretty stinking easy because you just take the constant. But this, since it's in a slightly different form, we need to expand it a little bit. Okay? So, for your for your y-intercept, always think x equals 0. All we're going to do is substitute 0 in for our x here. So y equals 1/4 0 minus 3 squared plus 1. So we're just going to solve for this y. So then we have y equals 1/4 times 9. Negative 3 squared is 9 plus 1. Going to do this fast, folks, but 9 over 4 plus 4 over 4. I'm getting it into the form already that allows me to have lowest common denominator. So then y is just 13 over 4, which is 3 1/4. Okay, so that takes a little bit more. The x-intercepts, we want to think y equals 0. So we go to the original equation and we write down 0 equals 1/4 x minus 3 squared plus 1. We want to subtract 1 from both sides. Negative 1 equals 1/4 x minus 3 squared. Multiply both sides by 4 to get this fraction out. Negative 4 equals x minus 3 squared. Okay, at this point, let's just hold the phone. Can anything squared be negative? No! Unless we're talking about imaginary numbers, but we're not, so no! Okay? So then we know, since something squared can never equal a negative number, we have no real roots. No real roots, that means that it doesn't touch the x-axis. Okay? It's not our typical parabola where we're going like that and having 2 spots. It's opening up, so we know that it's going to look something like that. It's not going to touch those x-axes. Or sorry, that x-axis. There's only one of them. Think about it. What else do we need to do here? Domain and range. Well, I'm going to go with V here. The domain, real easy. X, E, R. X can be anything. The range is a little bit more tricky. We have Y such that y, since it's opening up, it's going to be greater than, so y is greater than or equal to. We're going to look at what our our y variable for this is. It's 1. Y is greater than or equal to 1, and y is also an element of the reals. All right? Okay, it's graphing time. Just going to give you a nice little shot that you can pause to catch up. Okay, let me erase this thing. B, graph it. See how fast you can draw a graph? Make sure that we have our scale in here. I want each tick mark to do that. So I know that it's opening up, but the first place that you should probably start is the vertex. I know that it is 3 and positive 1. And it opens up, so it's going to go in this shape here. Now, officially on the grade 12 provincial exam, to graph something, you need to have 2 distinct points. So what we're going to graph here is what we would usually do is we would graph our vertex for a quadratic, a vertex, our y-intercept, and our x-intercept. But guess what? There are no x-intercepts. There are no real roots. There's no solution when y equals 0. We can say it all kinds of different ways. Anyways, it doesn't cross this x-axis, but it does cross the y-axis. And where is it? It crosses it at 13 over 4, which is 3.25. Okay? So we know that this is actually quite good. We have 2 points. And when we're saying sketching, like, it's okay. I just need to see that, number 1, it opens up. Number 2, it has that parabolic shape to it. And number 3, if there are any y-intercepts, which there actually always will be, folks, think about it. A y-intercept, then that's good. So vertex, y-intercept, and if there are roots, make sure you graph them. If I really wanted to be a stickler about it, I would say y equals 1/4 x minus 3 squared minus 1. Nope. Plus 1. Ha, caught my own mistake.